Okay, so now we will look at a new concept here. This is basically a circle, and let's say you have a point A, B, then you have point C, point D. So if you join AB, AC, CD, and BD. So what is ABCD? It is a quadrilateral, right? But all its four vertices are lying on the circle. So this is a cyclic quadrilateral, right? So we have a property for this particular type of quadrilateral. The vertically opposite angles, if you take the sum of vertically opposite angles equals 180 degree. So angle CAD plus angle CDB is equal to 180 degree, and similarly angle ACD plus angle DBA is also equal to 180 degree. Okay, so we'll try to prove that. So what we will do is we will join these four vertices. Okay, so we will so now let's see. So we basically have to prove this, right? So how do we prove that? Okay, so CD is subtending angle CAD, right? So let's say it is X. So if you look at angle CBD, these two, because it's the same chord, or you can say the same arc subtending the angle here, therefore this also will be X. We know this property. And now consider this angle, this chord BD. So BD subtends, say this subtends Y here, right? So the same BD also subtends BAD, angle BAD. So that is also Y, right? AC subtends angle ADC and also angle ABC. So let's call this Z, and then this also is equal to Z, right? Same way, you can see AB subtends angle ACB and angle BDA. So we can call it K, and this is also K. Okay. Now if you notice, in triangle ACD, right, angle CAD, which is this angle, plus angle ADC plus angle DCA, this equals 180 degree. Okay, so now if you substitute the values, so angle CAD is what? X, angle ADC is what? Z, angle ACD is what? K plus Y. So this is equal to 180 degree. Now if you rearrange it, what happens? So you can have X and Y together. So X plus Y plus, you can have Z and K together, right? So it's the same thing, right? This is equal to 180 degree. So what is X plus Y? X plus Y is angle. So let's put it in bracket for easy understanding. So X plus Y is what? Angle CAB, right? And what is Z plus K? That is angle CDB, that is equal to 180 degrees, right? So this is proved. Same way, if you look at this triangle ABD, right? So in triangle ABD, if you take the sum of all the angles, so X plus Z plus Y plus K is 180 degrees, right? So you can again see that x plus z is what? X plus z is angle ABD, angle ABD, and y plus k is what? Angle ACD, and that is equal to 180 degree. So the second part is also proved, right? So this is what is called a cyclic quadrilateral. The converse is also true, as in like if the opposite angles of a quadrilateral sum to 180 degrees, then they are cyclic quadrilateral. Okay. Okay. So they have a few questions here in the NCERT textbook. We can try to solve these questions here. So if you look at this, so what are they saying here? So we have example 3 here that we can look at. So here, if you notice, what is this saying? So this is saying figure 10.32, which is this figure, right? Here. Here, AB is a diameter of the circle. So this is the diameter of the circle and center is O. CD is a chord equal to the radius of the circle. So this chord CD is equal to the radius of the circle, right? AC and BD when extended. So AC and then BD, when they are extended, they meet at E, right? So we have to prove angle AEB is equal to 60 degrees. So angle AEB, we have to prove that it is 60 degree, right? Okay, so how is it trying to prove that? So it made some constructions first. So they have done this construction. So they have joined OC, OD and CB or BC, right? Now OCD, because CD is equal to the radius of the circle, right? And OC and OD are also radius, right? Then triangle OCD is an equilateral triangle, right? So OCD is nothing but, or angle COD is equal to 60 degree. So this angle here, right? This is 60 degrees, right? So COD is 60 degree because this triangle is equilateral, right? So what is CBD, right? What is CBD? CBD is half of angle COD. Why? Because CD is subtending angle COD at the center, right? Same CD is also subtending angle CBD. So we proved a property here, right? That whatever is subtended by the chord at the center, at any other point on the circle, the value of that angle is half of what it subtends at the center, right? So by that logic, CBD is half of COD, right? Which is what they have said here, right? And then what is half of COD? COD we know is 60 degree, right? So half of COD is 30 degree. And angle ACB, right, is 90 degree. Why? So diameter is also the chord of a circle. It is the longest chord. So how much angle does this straight line AB subtend on O? This is 180 degree. And any other point where this will subtend, it will be 90 degree, which is half of 180 degree. So same theorem. So we have angle ACB is nothing but 90 degree. So what will be angle BCE, which is this angle, right? This angle BCE, this angle, right? That is what? 180 degree minus angle ACB, because angle ACB, this angle, this plus this is 180 degree, and angle ACB, we saw it as 90 degree, right? So angle BCE is how much? 90 degree. So this is also 90 degree because this is 90, right? So we have this angle as 90 degree and then you have this angle as 30 degree. So 90 plus 30 is 120 degree, right? And in triangle BCE, this BCE angle plus angle CBE plus angle CEB. In that triangle, the sum of these angles will be 180 degrees, right? So what will be angle CEB? That will be 180 degree minus the sum of these two. Sum of these two is what? 120. So this will be 60 degrees.